Welcome back, folks. Today our project is ice machines. So I've already started this machine up. It's already made one harvest of ice. So you can see it in there. So right now I'm on the second harvest. This is the on-off switch and also the wash switch. This is the purge. So if you want to get rid of all the water in the sump here, do maintenance on it, you use the purge. So right now you can see that the lines are starting to frost up. You have water circulation through. Now here's something to note. I am not using a regular set of gauges on this machine. Reason being, the charge is only 25 ounces. So we use these little stub gauges. Because as you can see, I've got 3 or 4 feet, almost 5 feet of hose. That would take anywhere between 2 to 4 ounces each line. So I could theoretically take a quarter of my charge using a regular set of gauges. So right now, we're at about 180 psi on the head side, and we're at about 40 on the suction side. This is an R404A system. Now, when the water first filled this bin, it was 75 degrees. The suction pressure was then somewhere around almost 50 psi. So now that the temperature has dropped down to 32, and the water temperature in the bin is 32. So now you can see, actually there's even more frosting going on right now. So as the lift pump cascades water over the grid, which makes the ice cubes, what happens is it starts freezing from the back to the front. That's why in the case of commercial ice, you see no air bubbles trapped in the inner portion of the cube, like we do at home. You get that cloudy ice cube, doesn't look real good. Well, commercial ice freezes from the inside out, so it doesn't trap any air within the ice cube itself. So as this cascading effect is flowing over the top of the grid, it continually makes ice until it gets to the front edge of the grid, and there is a sensor, a switch, that will tell it when to switch into the harvest mode. Now in this case, this is a very ingenious design, because what it does, when that limit switch comes out and turns on, then it will go into a hot gas harvest. So there's a solenoid valve that bypasses the hot gas coming out of the compressor directly into the evaporator, heats the evaporator, and allows for the harvest. So while we're waiting for that to happen, let me explain what you're going to start seeing. So we were at about 180 when we first started, and we were at about 50. So now my pressure has dropped down to about 35 psi, and my head pressure is now about 160. So the pressures are slowly coming down. As we know, we have a temperature-pressure relationship. So as we remove the heat from the actual ice, the pressures in the system are going to come down accordingly. And now you can see that there's even more frost buildup, which is telling us that we're going to be close to a harvest soon. So while we're discussing that, let me talk about something that, here's one of the major components that fails. This little pump right here. So obviously, if we're not able to pump water up and over the grid, we're not going to be making ice. And this is a perfect time with what's going on here in the country to talk about sterilization practices. Gentlemen, ladies, one thing we can't afford, this is a food product. So when we're working on these, it's important that we use, and now it's called personal protective equipment. So the thing of it is, not knowing what you're carrying, not knowing what you come in contact with, now you're going to go into a hotel or a bar or a restaurant and you're going to do a service on their ice machine. Well, where have your hands been? So here's the thing, guys. We need to use a ice machine cleaner each and every time that we service a piece of food grade equipment, and this is food grade product. We need to make sure that we have the proper safety features, safety garb, gowns, gloves, whatever it takes, protective eyewear. My glasses are over there right now. So we'd use a power sprayer like this. We would take our solution, put it in here, pump it up, pressurize it, and after we're done with our service, what we would do is we would spray down all the surfaces. We would rinse thoroughly, because you want to leave any of the sanitizer or sterilizer in the ice machine after the fact. Now there is a drain at the bottom of the bin, so as you're rinsing everything down, it's going to go directly out the drain into the floor. So again, guys, last step of the process is to actually do the cleaning. That may be one of the reasons why you're there. There may be crud buildup, there may be algae starting to form. One of the other common problems with ice machines is the water filters. Multiple filters are used most of the time on ice machines. So we'll have anywhere between 1 to 4 filters per machine. Those are a problem. Okay, that's a source of low water flow, low ice production. The other thing too is now we're starting to hear some crackling going on here. What that is the ice is starting to expand and it's putting a little pressure on the grid. So as I've told you guys before in troubleshooting, your senses, your sense of hearing, your eyes, your touch, smell sometimes, all come into play when we're trying to figure out what exactly is happening. So this little crackling noise that I hear is telling me that I'm soon going to have a harvest. And how I can tell that now is I've even got more frost that's basically, it's turned these pipes white. So the float switch has kept a constant level in our sump here. So as the ice gets made, this water level drops. So this little float switch enables us to maintain a constant level. And as you might be able to hear, there's some crackling going on. And what that is the expansion of the grid. So it's the ice actually expanding the grid, putting some pressure on it. And the other thing that we can see is our temperature and pressure is now dropped. We're down to about 30 psi, and we're down to about 155, 160 on the head. So the next thing that's going to happen is we're going to go into the harvest mode. You're going to see the low pressure gauge go up into the nether region here. Basically, you probably won't be able to see it. But what's going to happen is it's going to direct discharge gas directly into the evaporator. So whatever we have coming out of the compressor, right now it's about 155, 160 psi, will present itself right here on the low pressure gauge. That's perfectly normal. So we're starting to hear a little more crackling. So we should be approaching a harvest cycle quickly. Now, one of the things that affect harvest cycles are the ambient temperature that the ice maker is in. So in other words, if we're in a hotel, we have a nice air-conditioned hallway. There we go. So right now, you can see that the frost that was here has completely melted because we have hot refrigerant being pumped into the evaporator, and now it's actually making its way out of the evaporator. So now you see we have clear copper here, we have clear copper here, and the actual temperature of this line is quite warm. So it's somewhere around about 150 degrees. Now in a few seconds, we're going to heat that ice grid up enough that gravity will take the ice out of the grid for us, dump it right into the bin. The next thing that will happen is you'll see that we're going to get a fresh batch of water that roll in, and you're going to see the pressures are going to go back up because this water is coming in street side about 75 degrees. There's our harvest. So now one of the things that we do is we would take time samples. So right now it's quarter to the hour. Now we're doing a fresh fill here. We have the float that's going to maintain a certain height here. And this little valve right here is allowing city water to come in and fill our sump. So now what's starting to happen is the sump is filling back up, the refrigeration cycle is kicked back on. Now we're seeing that the suction pressure has gone up a little bit, and we're at just about 50 psi, and our head pressure has gone up because now remember we've got 75-degree water in here. So within a few minutes, this water temperature is going to come down to 32 degrees in the sump, and that's going to be reflected here on the suction pressure. You're also going to start seeing the head pressure start to come down as the refrigeration system starts to catch up to the load, and the load is being the fresh water that just came in. So what we're going to do basically is we're going to subcool this water from 75-degree ambient temperature to 32 degrees Fahrenheit. Now remember, we can have water at 32 degrees, and as long as it's moving, it will not freeze solid. So there's that extra latent heat that we have to remove to make it a solid. So as long as it's rotating through the pump and it's coming up over the cascade, down over the coil, we're fine. Alright, so again folks, this would be the time right now where if I was to get this machine ready to put back into production again, so I would have my gloves on, I would already have my ice machine cleaner mixed up, I would do a spray, any surfaces that I touched, I would cover. Let me just pull these off so we can just take a quick look underneath. So again, these have check valves, that's why you can still see the pressure holding. So the whole purpose of using a gauge set like this is to remove the minimal amount of refrigerant, and that would be called the de minimis release. So now we put the caps on. It's very important, folks. The Schrader valves are always a source of leak. So I'll take the wrench and I'll just give that a little quarter turn. But so underneath here is where the grid is. So if I'm going to do a cleaning, what I'm going to do is I'm going to spray. I can remove this cover if necessary. I'm going to spray the entire grid. I'm going to spray the sump. I'm going to spray the entire bin. And I'm going to make sure that I cover all the areas. Because remember, folks, there's kids running down the hall of the hotel that think nothing about sticking their little fingers in here, and even some adults. So we have two purposes here. Number one, we have to clean up after the customers, and number two, we have to clean up after ourselves. And at a time right now where the coronavirus is at the forefront of everybody's thoughts, you can see how important that might be in doing a good service on an ice machine, which, remember, the ice cubes go in your cocktail or they go in your glass of soda. And when the bars and the restaurants open again, you want to make sure that the ice that you're drinking, or the ice that's in your drink, is as sterile as it can possibly be. So just wanted to cover that point for you. We'll be doing more videos soon. I have a couple on, I'm going to do a walk-in cooler. I'm going to do some more advanced work. We have the chiller across the hallway, or across the parking lot rather. I'm going to do something on that for the senior guys. All right, see you soon.